y equals 6. So typically what you've done in the past is you would just solve for y, right? So if I divide both sides by x, you get y equals 6 over x. If you're graphing that, I'm thinking, put together a little table of values, right? When x is 1, what's the y value? What's 6 divided by 1? 1, 6. When x is 2, what's the y value? 3. When x is 3, the y value is 2. Plugging in an x of 4 is not really worth talking about. What is 6 divided by 4? 1.5, yep. So 4, 1.5. 5 is even trickier. Let's just jump right to 6. If I plug in a 6, 6 divided by 6 is 1. And then what about if I go backwards? What if I plug in a 0? No. It does not exist, right? You can't divide by 0. So there is no point at 0. What is at 0? Because you've done these types of graphs in Algebra 2. Asymptote. So as we get closer and closer to x of 0, we're going to shoot up towards infinity, but we're really never going to touch the y-axis. And similarly, as we go that way, it's going to get smaller and smaller towards 0, but never actually going to touch it. But then if we do in the negative direction, like -1, what will our y value be? -6. So this is like a totally separate piece of the graph. -1, -1, 2, 3, 4, 5, 6. If I plug in -2, I'm going to get -3. -3 is going to give me -2. I'm just going to jump to -6, -1. So similarly, on the other side, okay, that's a rational graph. Can you see kind of that idea, though, of two parabola-ish like things backing up against each other? It's just sort of diagonal. Like if I turn my paper, you can see it a little bit more. So there's a connection here between rational graphs and hyperbolas that we'll get to. On this next one, if I want to do a similar thing, I'm going to multiply both sides by y. Well, or cross multiply, because really you guys are used to solving for y, right? So if I cross multiply, I'll get xy equals -8 and divide both sides by x. It's going to be very similar. Just to save us the time, I'm just going to type it into your calculator and show it to you. -8 divided by x, zoom 6. Of course, I picked the one with bridge. I can never see it. They always pick it. -8 divided by x. Because it's negative, it actually got sort of flipped upside down, first of all. Because do you see how this one, a positive 6 over x, is first and third quadrants? This one's second and fourth because of the vertical flip. And it's also a little bit stretched or compressed. I'd have to kind of figure out which one. But it's just a little bit morphed because the 6 versus the 8. But the point is it still has a hyperbola-like feature. Okay? All right. So, you know what I'm going to do? Let's jump right to the example, because I think it's confusing when you have nothing to like latch onto if I just start throwing vocab words at you. So let's first look at the equation. What is different about the look of a hyperbola equation as it compares to the ellipses that we just came away from? It's a minus sign. That's really it. It's a minus sign. And so if you see that, you need to be thinking hyperbolas, okay? But there are a lot of commonalities. And the first is like, there's not really a center of a hyperbola the way there's a center of an ellipse, right? Like an ellipse is a circular shape, so we could go to the center of it. But like if I'm showing you this hyperbola, the center is like in here. So the center is still going to be a similar concept. What would you say the center is? Change that. No, the x-coordinate has to come first. -2, 4. The ellipses did that too. If they wrote the y squared first and the x squared second, the ellipses did that too. Because do you remember, where's my ellipse structure? If I go back here, and we talked about how really truly with ellipses it does not matter because of the plus sign, but they always put the bigger number first. So if it was stretched in the x direction, they put the x binomial first, and if it was stretched in the y direction, they put that y first. So if it was ever in this format, your center was still HK. Your x coordinate is always paired with the x, and your y coordinate is always paired with the k, or with the y. Does that make sense? So usually when I wrote ellipses, because it's addition, you can flip-flop the order. The thing with hyperbolas being subtraction is we can't flip-flop the order. We have to keep the bigger one first. Does that make sense? So your center is -2 because that's paired with the x, comma 4. Okay? So I'm going to sketch that. Try to think the best spot to put the x-axis. So it's, I probably shouldn't have done that, but I'm not going to. I'm just going to hope and pray that we. Okay. So that's the center of what for you guys is going to be a guided like rectangle. And we're going to draw a rectangle, you'll see, and use that as a guide for our parabola. And the rectangle is getting stretched from that center 4 units. Does everyone see where I'm getting the 4 from? 4 units up and down. So 1, 2, 3, 4, and 1, 2, 3, 4. And 3 units left, right. So 1, 2, 3 to the left, 1, 2, 3 to the right. So very lightly sketch a rectangle. The diagonals of these rectangles are going to provide like a boundary for us. So if I'm going to extend these diagonals outside and extend these diagonals outside there. Wait till it comes full circle here. You'll see, when you see how I use this, you're gonna get it. So if I look up at my 2 structures for a hyperbola, is this the first one or the second one? It's the second one because the y is coming first, yes? So what is my A value? And what is my B value? Yeah, we do. 3. And there, just like there was with ellipses, there's this equation, and this one truly is the Pythagorean theorem. A squared plus B squared equals C squared. A is the center to a vertex. So, A was, what did we say? 4. And we stretched that in the y direction. So this is a vertex of a parabola, opening and squeezing between those 2 diagonals, and going 4 units in the other direction. This is a vertex, and you just kind of draw a parabola using those diagonals as your guide, and that's the graph. Yep. This part is all not really part of the graph itself. It's just a guide for where that parabola should, how wide that parabola should be opening. A guide. The hyperbola itself is just this structure right here. You just kind of draw, once you get the vertex, you just kind of draw it. So the question is, how do I know? Because sometimes they open left-right, and sometimes they open up-down. Whatever the A distance is, that's the way it opens. So this opens up and down. So my vertices are the up-down ones. No, they're not. Hold on. Wait, we're not done yet. Because there are still these focus points that we need to figure out. But again, we're just going to do, and it's very similar to ellipses, just a different formula. This one truly is the Pythagorean theorem, so that should be easy to remember. A squared plus B squared equals C squared. So C is going to equal what? 5. So your focal points are 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Because you'll be asked for them. Do you remember with parabolas you had focus and directrix? You had a focus and you had a directrix. Here you just have two focuses because they're kind of opposite each other. And the directrix is really, and you don't call it a directrix here, but it would be like the line that's halfway through your rectangle. Your focuses with parabolas and your focuses with hyperbolas are always bold. They're in the bowl. If you think of this as a bowl, they're always in the bowl. With an ellipse, they're inside the bowl. It's just with the ellipse, if you flip this one down and flip this one up, it would probably come together like an ellipse. I wouldn't try to draw too many comparisons between the focus of an ellipse, because an ellipse is an entirely different shape. But you can definitely draw comparisons between the focuses of these hyperbolas and the focus of a parabola, which you did last year. A parabola is a conic section. Like in Algebra 2, there used to be an entire chapter of conic sections. Circles, parabolas, which we still do in Algebra 2, ellipses and hyperbolas kind of complete that picture. Does that make sense? I did it all at once. It would 25 equal C squared. So I did. I just skipped some steps. So find the center, done. Find the foci, we could count those and we could come up with that point. -2, 0, and -2, 9. Oh, it's not 0. It's -2, -1. -2, 0. -2, 5, 6, 7, 8, and -2, 9. So you could just count those out. So we've got the center, focus, vertices. Got it? All right. That's just one under our belt. Let me just go back up. There's a couple things that were talked about up here that we didn't get to that really aren't as important for coming up with the picture, but let's talk about them. So now that we have some context, the ellipse, that's a typo, the hyperbola is the set of all points such that the absolute value of the difference of the distances from two given points called the foci is constant, 2a. Over our heads. You're never going to be called on to to know that at all. So that's just doing due diligence and telling you what a hyperbola is. So the center of the hyperbola is the midpoint of the segment connecting the foci. So we didn't really get it that way, but if you connect your foci, the center is right in the middle of that, right? You could also connect your vertices, and the center is right in the middle of that. These two, the transverse axis and the conjugate axis, those are new vocab words. So the transverse, or the major axis, is the line segment containing the foci, length 2a. So where does she have that in the picture? The line segment connecting the foci She doesn't have a picture of it. Oh, just this to this, the two focus added together. Yes? So let's check that. Apparently it's supposed to have a length of 2a. If I connect my two foci here, from here to here, how long is that? From -1 up to 9. 10. Is that 2 times our A value? No, it's not. It's 2 times our C value. Let me get back to you on that and see if that's a typo. The line segment connecting the foci should have a length of 2a. I'll get back to you on that. The conjugate axis is the minor axis, the line through the center, so here's our center, and perpendicular to the transverse axis, so here. And it has a length of whatever double B is, which I would say is 1, 2, 3, 4, 5, 6. So a length of 6, which is double B. Yes? So that one works out. Still going to check on whether or not that's a typo. Vertices we've got. Point of intersection of the hyperbola and the transverse axis. You know what? I think that's the typo. I think it's the line segment containing the vertices, not the line segment containing the foci. This is the major axis, just like it's the longer way across the rectangle, and this is the minor axis. Do you follow that? Cross out foci here and put vertices, because that would make more sense. Just like your major and minor axis in an ellipse connect the opposite vertices, the major one's the longer, the minor one is the shorter. Here's your major, here's your minor. That's just to summarize that more easily. That's, again, these words make it more complicated than it really is. Vertices we have, that's the point of intersection of the hyperbola and the transverse axis, which was the major axis here, so that makes sense. Your asymptotes are these lines which the branches of the curves approach. These are those asymptotes right here. Do you follow? Okay? So that's, and then, oh, we have a lattice rectum here too. A chord through the focus. It's not really a chord anymore because it's not an ellipse, but it's a segment, we'll say, through the focus. The length of the lattice rectum of a hyperbola is 2b squared over a. So a line segment through the focus. I'm going to guess that it's this line segment right here. The length of that. That's your lattice rectum. Follow? So you visually, you know how it kind of went across that little like scooped part of an ellipse? It's kind of doing the same thing here. And whether you look at the length of the lattice rectum here, or there's another one down here, that's a lattice rectum. Capiche? Okay. All right, let's go to the next one. Oh, we don't have time for this. All right, so that'll just be our one. Your homework. I want you just to do, nope, 2 problems. 4 and 8. And Maddie's going to pass back your trig test.
Yeah, Maddie.
Do 4 and 8.
Yeah.
I'm probably going to say Tuesday.
Oh, I knew it, dude. I knew it.
Maya, can you get that started for me, please? I'll have to